Hey guys, Mr. Wiegand. Today we're going to look at exponential growth and decay. So on the left side here, this would be growth. It's starting off low and it's slowly increasing, then it just shoots up sharply. Exponential growth really goes up quickly. This would be our decay. And decay is starting high and drops sharply and then kind of levels off. Both these graphs don't really touch the x-axis, they just get real close to it. Both of these, we're going to use the same formula, y equals a times b to the x power. Okay, but we have some different constraints. For the growth model, a cannot equal 0, b has to be greater than 0, and b cannot equal 1. For the decay model, a cannot equal 0, or a has to be greater than 0, and b has to be between 0 and 1. Okay, so think of it like a fraction or a decimal in between 0 and 1. Alright, so we have growth and decay. What I want to do here is I want to write a function for each of these based on the tables. So we know that we're using y equals a times b to the x power. So I have to figure out what a and b are in this problem. Alright, first off, I'm going to look at my y values. What do I multiply by 1/2 to get 1? What do I multiply 1 by to get 2? What do I multiply 2 by to get 4? What do I multiply 4 by to get 8? If I can find the same number for each of those, then I know that I have an exponential function, and that number will be my b value. So it turns out that each of these is multiplied by 2. So I know that I can put 2 in for b. I still don't know a yet. Alright, now to find a, I simply need to pick an x and a y coordinate from my table, and the order pair will work. But if you choose this one right here, when x is 0, the problem turns out to be fairly easy. You'll see. So I'm going to put 2 in for my y value, put 0 in for my x value. So 2 goes in for y, a I still don't know, and x is 0. Right, now we all know that 2 to the 0 power is just 1. So on the right side of this equation, I end up with a times 1, which is just a. On the left side of it 2, and a turns out to be 2. Real quick, easy way to figure out a. So now I can plug that in. Y equals a is 2. B we already found out was also 2 to the x power. And then that is my growth function. Y equals 2 times 2 to the x power. Alright, same idea over here with decay. We're going to use y equals a times b to the x power. I'm looking to see what do I multiply to go from one number to the next. And it looks like I'm multiplying by 1/2. So my b value is going to be 1/2. Alright, once again, to find my a value, pick an ordered pair. I'm going to choose this one where x is 0 and y is 2. Plug those numbers in. So put 2 for y, 8 we don't know, put 0 in for x. Okay, 1/2 to the 0 power is 1, so I'm left with 1a on the right, a equals 2. So now I have my a and my b. Y equals a2 times b 1/2 to the x power, and that's my decay function. Okay, so that's writing a growth or decay function from a table. Alright, now we also graph. So let's say this is a growth function, y equals 3 times 2 to the x power. I want to graph this, so I am going to make a table. I'm going to pick some x values, and I'm going to plug them in and find out the y values. Now, I'm picking small numbers, because you'll see as this grows exponentially, the y values are going to go up real fast, And we're probably not even going to fit all these on here, but we'll get enough on here to get an idea what it looks like. Okay, and don't forget, we know from when we saw the introduction to this, it's going to look something like that. And that's the way the growth model looks. Get that out of there. Okay, so if I put -2 in for x, 2 to the negative second power would be the same as 1 over 2 to the positive second power. We learned that earlier in the chapter. And then 1 over 2 to the second power is 1/4. 3 times 1/4 is 3/4. If I put -1 in for x, 2 to the negative first power is 1 over 2 to the positive first power, which is 1/2. 1/2 times 3 is 3/2. If I put 0 in, 2 to the 0 power is 1. 3 times 1 is 3. If I put 1 in for x, 2 to the first power is 2. 3 times 2 is 6. And if I put 2 in, 2 to the second power is 4. 3 times 4 is 12. And so I can plot these points. All right, now -2, 3/4. All right, -2, 3/4 is a little less than 1, so I'm going to go right about there. All right, -1, 3/2. -1 and 3/2 is right there. Okay, now when you get these fraction y values, you do the best you can. You're not always going to get it perfectly. These actually aren't that bad, but sometimes you'll get like 1/8 and 1/12, and you really have to kind of get it in there. All right, 0, 3, 1, 6, 2, 3, 4, 5, 6. And then we're not going to fit 2/12. We know it's going to be, up top somewhere. So then I know that it's going to go kind of flat down here and shoot up. I have an arrow on there. I have an arrow on there. Down here, this actually is not going to touch the x-axis. It just goes closer and closer to it, and going to go on and on forever to the left. All right, now we might also, once we make a graph, ask for the domain and the range. Domain, we know that's our x values. So this arrow is telling me it's going to the left forever. If you look up here, it's not going straight up, it's going on an angle, so it's also going to the right forever. So if this graph is going to go to the left and to the right, then I know that my domain is all real numbers. My range, well, it's going up forever, infinitely. But when I go down here, like I said before, it's going to get close to the x-axis but never touch it. So it's getting close to 0, but it never quite gets there. So my y values are going to be all the y values greater than 0. That's my domain and range. All right, decay. Same idea. We're going to make a table. I'm going to put numbers in for x. Same kind of numbers. I want to keep them small. We have y equals 3 times 1/2 to the x power. All right, so if I put -2 in for x, 1/2 to the negative second power will be the same thing as 2 to the positive second power, which would be 4. And then 3 times 4 is 12. If I put -1 in, 1/2 to the negative first power is the same thing as 2 to the first power. 3 times 2 is 6. If I put 0 in, 1/2 to the 0 power is 1. 3 times 1 is 3. Put 1 in, 1/2 to the first power is 1/2. 3 times 1/2 is 3/2. And then if I put 2 in, 1/2 to the second power is 1/4. 3 times 1/4 is 3/4. Right, so similar numbers than the last example, but this is going to be decay, so you are going to see a graph that looks a little different. All right, so -212, I'm not going to be able to fit that on. If I come over here to -2, I know it's going to be up there somewhere. All right, -1, 6, 2, 3, 4, 5, 6, right there. 0, 3, 1, 3/2, 2, 3/4, and it's going to come down sharply, curve, steady out, and like I said, kind of goes along that x-axis forever. All right, so let's do domain and range for this also. It's going to be very similar. If I see this is going up on an angle, so it's actually going out this way forever, slowly, but it's going that way. It's going this way forever, so just like in the previous example, it looks like my domain is all real numbers. My range is going up, for infinity, forever there. And down, though, it's down here. It's going to keep going along that x-axis, never quite touch it. So, once again, y greater than 0 will be my range. All right, so that's the growth and decay, exponential growth, exponential decay. You saw tables and writing the functions, and then you saw functions and then graphing them. All right, good luck, guys.